So this is the third of our properties of exponents. Here's where it comes from. 3 to the fourth means take 3 times 3 times 3 times 3 4 times, right? And 3 to the second means take 3 times 3 2 times. So what our goal is to figure out what is the power on 3. How many total 3's do I have? Yeah. I have 1, 2, 3, 4, 5, 6 3's, so we call that 3 to the 6th power. Okay? So when you're multiplying two numbers, we can, by definition, write out how many copies of that number we're multiplying. And then if they're all the same bases, add them up, and that's our power. For example, here I have 2 x's, and then I have 1, 2, 3, 4, 5, 6, 7 x's. If you total those up, you'll count 1, 2, 3, 4, 5, 6, 7, 8, 9 x's. So this is x to the 9th power. Now you're probably starting to, we're getting there. You're probably thinking right now, we really don't want to list all these out and count them. That is not the most efficient way to do this. If you have 3 sets of things here, I have 3 2's for that first term, another 3 2's, and then this is something you need to understand. This is 2 to the first power, not the 0 power. So there's an unwritten 1 on there. So that gives me another 2 to count up. So what I'm doing here works no matter how many terms you have. And towards the bottom of the classwork page, you'll see that we have multiple numbers or letters, the powers to add up. So here I have 1, 2, 3, 4, 5, 6, 7. So here's the deal. There's no way we're going to want to write them all out and count them. There's got to be a better way. Yeah, what are you noticing? Just count the exponents. In other words, if you look at the exponents here and here, how does that compare to this? You added them, yeah. What about here and here? Add them. What about here? There's 3 of them here, but what do they add up to? Okay, so the rule is, if the bases are the same, and you're trying to multiply the numbers or letters, you add the exponents. That's the rule. Okay, so the rule is, if the bases are the same, add the exponents. Write this down. If the bases are the same, add the exponents. That's the rule. That's the only rule that's the new rule for today. I won't say it's the only rule we're doing. We're still going to be using the negative powers. They'll show up in today's classwork, and 0 powers. When you see a negative power, what do you have to do to make it positive? Yeah, and if it's in the denominator, then what do you do with it? If it's negative and it's in the denominator? Put it. Yeah. So that still holds. What if you see 0 powers today? Change that out to a 1, yeah. So those are still going to show up in today's classwork. The goal is that we'll have 5 rules of exponents, and you can use any of those 5 to simplify an algebraic expression with powers, okay? We'll eventually get to that skill, maybe at the end of next week, I don't know. Okay. No. All right, so let's see what we have. All right, on to the next page. Give me all kinds of messages here. Okay, let's use our new rule. This is equal to 12 to what power? 12 to the, that's right. It's 4 plus 3, or 12 to the 7th. Now, Okay, we add the powers and keep the base the same. Don't add the bases. It's not 24 to the 7. The bases stay the same, and we add the powers. What's this one going to be equal to? To the 5th, because you're going to add the negative 2 plus 7, which is negative 5, to the 5th. So we're not going to list them all out like I did in the beginning and count them. We're just going to add the powers. Okay. And you can even, something like this, 12 to the 7th, is a very big number. You can just leave it 12 to the 7th. I'm really just focusing on the rule, yeah, adding the powers. All right. Down here, this is what you'll see towards the bottom of your classwork. See how we have numbers being multiplied and letters being multiplied. Now the numbers are not the same bases. 4 and 9 are not the same. Okay. So we multiply the 4 and the 9. Now the z's are the same bases, so we're going to take z, write it down, and then add the 2 powers that you see there, 5 plus negative 12. So the 4 and the 9, just multiply them to get 36. The z is equal to whatever 5 plus negative 12 is. Negative 7. So z to the negative 7. And just as we did 2 days ago, we cannot leave that z to the negative 7 there. It's not in simplified form if there's a negative power on anything. So what do I do next? Draw my fraction bar. What happens to the 36? Well, what's the power on 36? 1. So does it stay or move? It stays up top here. Now the z to the negative 7 drops to the bottom and becomes z to the 7. So as you're going through and doing your rule where you're adding powers, you may get a 0 power, or you may get a negative power, and you need to use the rule from last time. Okay? What about this second one here? Looking at just the numbers, we have 2 times 9 times 3. And then we have an a to, do you see it here? It's not written. Yes. A to the first. And then here, we have a to the second. So I have a to the 1 plus 2. So don't miss that power of 1 on the a. Okay? So if you guys see. So this is 54, a to the third, b to the fourth. The big thing on here is that you understand that we're not adding the numbers. We're multiplying the numbers. They're not same bases. We're only adding the powers. Also notice that a has a power of 1 on it. Don't miss that as you're going through and doing these problems. Okay, the application of this as you move into, if any of you take chemistry, I don't know where you're at, sophomores, you probably haven't learned in chemistry yet, but in chemistry, sometimes in other sciences we'll talk about, well, I would imagine in physical science too, physical and earth science, you talk about really large numbers and really small numbers, right? Chemistry, really small numbers. Physical earth science, maybe really large numbers. And we represent those numbers with what's called scientific notation. You may have heard of that before. Scientific notation is this. It's a number of the form a times 10 to the n, where a is between 1 and 10. Okay, that's what this says here. You might want to write this down in words. A is between 1 and 10. Including 1, not including 10. So what we're looking for is a number, and it can be a decimal, but it's got to be between 1 and 10. So on this first scientific notation problem, do you see the 3 and the 2? That's kind of like the 3 and the 2 up here. We just multiply the 3 and the 2 together. So it's 3 times 2. But then this is not an x, this is a times. 10 to the, what do you think we do with the powers on the tens? We add them, yeah. The bases are the same, so we're going to add 7 plus 5. So that gives me 6 times 10 to the 12th power. So it's a way to represent a 6 with 12 zeros behind it. It's a 6 with 12 zeros behind it. Your calculator won't, I think it'll only take 10 digits on your calculator screen. So this is a way to represent numbers that are so big that it would go off of the screen of your calculator. Okay. So when we're dealing with really big numbers, so when you're talking about, light speed, distances that things are away from the sun, etc., then we use scientific notation. Okay. This other one down here, pretty similar. There's going to be one extra step though. 4 times 6 times 10 to the negative 5 plus 3 power is what I have. Now 4 times 6 is 24 times 10 to the negative 5 plus 3 is negative 2 power. So here's what needs to happen. 24 is not between 1 and 10, right? So this is not in scientific notation. It's in a notation similar to it, but not official scientific notation. So what I need to do right now is I have a decimal point at the end of 24. That's where the decimal would be if I were to write it. Okay? Which direction does the decimal need to move? Left. So it would need to move 1 to the left. And if I do that, it gives me a new number, 2.4 times 10 to the, let me ask you this. Would I need to multiply this by 10 or divide it by 10 to get a bigger number? So I'll ask it one more time. Do I need to multiply by 10 or divide by 10 to get 24, which is bigger? Multiply. So I need a positive 10 to the 1 there. And then I still have times 10 to the negative 2. So just double check this. 2.4 times 10 to the 1 would tell me to move the decimal 1 to the right, which would get me back to where I started. So this number, I've moved the decimal left 1. I need to add to power of 10. So if I go this direction, I'm going to subtract from power of 10. So final answer is 2.4. See how I have 10 to the first and a 10 to the negative second? If I add those together, I get 2.4 times 10 to the negative 1 power. And that's my final answer in scientific notation. So if I have to move the decimal to the left, I'm going to add to the power of 10. What if I have to move it left 2 places? How much will I add to the power of 10? Twice, yeah. If I have to move it 3, I add 3. Okay. If I have to go this way, go to the right, then I'm going to subtract from powers of 10, however many places I have to move the decimal. So you should write this down. This might help. This is the way I think about it. So if you finish the notes, looks like all of you are taking notes. So you got 30 of the 6 points.
I still have my phone and she's trying to take me for a minute. I got it.